Hello, everyone. Welcome to Hydra Book Reading Club, episode 15. And in this video, just like how we started exploring custom GLSL, like you define your own Hydra function, new Hydra function, with set function, we're going to explore further. In the last video, we did the source functions, like type src. We're going to look into other types as much as I can cover in this video. And if you are new to Hydra or if you are using it but not sure about what I'm talking about, there are a lot of videos I've created as a tutorial for beginners, intermediate, and this new series, or current series called Hydra Book Reading Club, which is more advanced topic, like more in depth. And this one specifically, the custom GLSL, is something that you need to have some understandings of how shader works and GLSL is coded, because this is different from Hydra, also different from JavaScript, which I didn't talk about last time. It's completely different syntax that is compiled in a different way. So if you're new to this, I'm not going to be like explaining the whole like topic about GLSL, because I think there are various tutorials from other people who may be more useful. So I assume that you know the basics of GLSL, and I'm going to talk about how Hydra is using it under the hood. But like, don't worry, I will do it like step by step. And even if you are not like sure about this or that, about certain things about GLSL, don't worry. We can also like experiment with like changing, numbers, changing slight things. Actually, that's what I'm going to do. Like, I'm not going to create like a brand new GLSL or like Hydra function, but I'm going to be like editing existing ones to understand what is happening there, and if we want like certain feature that Hydra doesn't offer yet, you can create it by yourself. And this I didn't really plan yet, but I might talk about like how to create your like plugin and contribute to Hydra. That would be amazing. But I'm not sure if I can go that far. But let's see how what we can create today. So this is the editor, and I'm gonna just shrink. Yes, kind of like nicely blending into this sketch by Zach. All right. So this is the Hydra book, and it's hosted on. Now it's on GitHub Pages. It's not glitch.me. It looks similar, but it's glitches.me, which is my own domain that I rent. I registered. And here, like, I didn't really talk about, again, like, there are examples that I created already, but this doesn't really cover so much about like how things work. It's more like practical guide for how to create things like chroma key and rotation and so on. So I'll just like skip all these things here, and what I need is this thing called set function. So I'm gonna just erase everything. And last time I used set function starting with, was it OSC or something? I forgot. Or like solid, or gradient, I think. So we covered this topic about source. Just as a recap, we have this inputs. This can be handy if you are like trying to package things, but for experimentation, we can just like keep it, forget about it for now. What's important is this chunk called GLSL, which is just a string. And by the way, this is JavaScript, the backtick that you can have multiple lines and closing the backtick. And depending on your keyboard, actually, it's sometimes like confusing where to like press this. It depends on your keyboard, international settings and so on. On the US keyboard, it's not my favorite, but I happen to use US keyboard, and that's like right next, like left of Z. If you're using Mac, maybe it's different for Windows and so on. So just consult your whatever keyboard setting. But fortunately, we don't have to type it. I'm not gonna like type this all like by myself. I'm gonna just like copy and paste this. But what I want to say is this chunk is going to be like passed to GLSL, and this itself is not a standalone GLSL code. And what Hydra does is like it's gonna like every time combine like, okay, this chunk is for OSC, this chunk is for scroll, this chunk is for modulate, and they kind of like nest them, combine them. That's like what Hydra takes care of it and makes a complete GLSL code that will be passed to the shader, and it's gonna generate the visuals. So like Hydra is actually like, it's like a visual engine, but it's not like engine itself. It's kind of like gluing what you create as a code from JavaScript, prepare the GLSL code, and pass it to GLSL compiler to show the visuals. And what I'm going to do today is about, for example, rotate. Should we start with rotate, or should we start with something simpler, for example, like scroll X? Scroll X here, because I think it's really concise and it's nice. The indentation is sometimes kind of tricky, so like maybe you want to download this whole file and open it in your editor so that you can like auto format it, for example. But it's up to you. And basically what, again, just like the type source, what we're going to do here is just plug this JavaScript object into set function so that we can make a new function. And again, like last time, if I start editing this without changing the name itself, I'm going to overwrite existing scroll X. So I'm going to experiment and make scroll X actually going like a vertical direction, like scroll Y. Then it gets so confusing. So I'll just make it scroll X2, just as a, my convention. You might agree or disagree, but I think it's nice to like not to contaminate or to like, intervene what's there already. Let's make a new namespace, quote unquote, that we can like, it's like a playground for us. So it's like scroll X2, or like, if you want to be like, just brand yourself, that's also possible. But I'll just keep it like this. And now you might notice if you watched the last video, we have used type SRC. This one is type called chord, like coordinate. And that's again different from what's like branded as a category. Like this is scroll X, which belongs to the family of geometry. But here it's just like a convention for Hydra, like because people don't touch this part so much. It's like a danger zone, but don't freak out. It's okay. It's called chord instead of geometry. And this part is like very important because this defines what you can do inside GLSL. In the last video, we touched source, the SRC, which is basically you get the position of the pixel as _st. We can look at it now, going up a little bit and quite further up. For example, like solid function. It's quite simple. Solid is like solid color, so it doesn't really matter which part of the image. Okay, like for example, gradient. It depends on the position. It has a variation of colors, and _st is basically x and y, like 0 to 1, 0 to 1, like 2 in GLSL, and this defines, or like this passes on like the value of the position of xy that we can use in the source. If you don't want, like in the solid, like it's just solid color, I don't care which position it is, you don't need to use it, but it's a useful information that you can use. And what's more important is that it returns vec4, which is, it can be xyzw, or you can interpret it as RGBA. And it's, in this case, I mean, this is more like how you see it, if it's a position in the like 4-dimensional coordinate system, or is it a color system? In this case, we see it as color, as like human, but computer doesn't care what we're talking about. It's just vec4, whatever. But in this case, if you take type source, you return vec4. Now, we're talking about type chord, and in this case, we're returning, I mean, this one is not very clear what is happening here, but underscore st is basically the same as what we saw in the last video, which is vec2, and it's the position of the pixel. And now what is happening here is we're taking the underscore st, this is like a given, right? And scroll x is again something that comes from the input. Time and speed, okay, time is like a global variable, let's say, that's available, that that denotes time, that changes over time. And again, this is different from JavaScript. You don't need the arrow function. I mean, you cannot do it in GLSL. And speed is again defined here. So if I want to say, okay, this is actually speedo, like I did like a silly change that I made last time, I have to also match the GLSL code here. So the same with this. It's a little bit confusing that, I don't know, scroll XO. This is I just intentionally changed it because it's the same like string as the name. I mean, originally it was scroll X, scroll X. They are totally different things. So just for the clarity, I just added this O to make it a bit, or maybe like underscore. It seems like you find your convention, but again, it's not like exposed. Like again, we're like in the danger zone. So the things that are not like really made to be like user friendly. So you have to be careful. Like it's our responsibility. I mean, everything's our responsibility. It's an open source project. There's no warranty. Anyways, so let's see. That. So what we're doing is we're taking this vec2 underscore st. So if we want to be like really verbose, we can also do it like vec2 st equals underscore st. Just to be sure that we're talking about st. And again, if there is an error in this code, I will not see the error because it's only evaluated when the code is evaluated as like not in the set function, but as Hydra code. If it's used as Hydra code, then finally it will be like evaluated and it will not generate error in the console down here in the Hydra editor. So we always have to open the inspector or developer tools on the side. And now I can try, basically like I haven't changed anything. So I can use it as scroll X out. Okay, so it seems like it's working. And if I add the second parameter, it's going to be like moving. I mean, it's basically the same as scroll X because I didn't really change anything, but I just introduced a parameter that's going to be used in the same way, so it doesn't really change anything. Now, something really interesting we can do is, I always talk about this, like using this modulate function to do same thing as scrolling, but in that case, things don't wrap around. I think I talked about this in the motion chapter, but also in other chapters as well, maybe in the intermediate tutorials as well. So there's this like counterpart of scroll X that I can do with modulate solid 1, 0, I don't know, 0.1 or something. This basically does scrolling. But the difference between this and scroll X is that if you exceed the window space, screen space, then it will not wrap around. Like if you do this with scroll X, 0.5, the difference is that now you see the shape on the right side as well, which is different from modulate. So you can think of like two variations of like scrolling. One is like the wraparound, like scroll X, scroll Y, or scroll function does. And also another variation that it doesn't wrap around. Is it like one better than the other? It depends. It really depends on what you want to do. Because, for example, this is ideal like when you're like making this kind of motion because it's going to just wrap around, and that's kind of nice. It will not go away. Because if you think about like doing this in P5.js, for example, I'm talking about P5.js as an example quite a lot, but like if you do like translate like really far away and draw a shape there, it will not appear on the screen. But imagine like it actually wraps around, then it might be handy. Like if you just draw something and it just appears here, just as a, wrapping around, it may be desirable in some cases. This is desirable, but if I say like noise texture, this is not really desirable because then you see this weird edge or the seam or whatever. That's not really cool. So in this case, I would rather have modulate and solid, and I might have time as a parameter of solid. Something like this. It's a bit too fast. I can make it slow down. This is really like a kind of verbose, this lengthy, wordy, not verbose actually, this is just wordy way of creating this scrolling, but without wrapping around. This is different because noise is like infinite texture. It's like infinitely big. Wherever you scroll, it has the texture. But shape is like this chunk in the middle. If you scroll too far, it will not show anything. So that's why like wrapping around is nice with shape, because shape is just shape in the middle and nothing like all like black outside the space. But noise is like infinitely large. Same family is like OSC, Voronoi. Those ones are like infinitely big. I don't know, it doesn't make sense, but it does. It is infinitely big. It's just like not drawn. But like shape or also like gradient is another like maybe like weird thing if you like scroll too far, because then it might be like too black or too yellow. I can try it actually. Gradient. Yeah, it's actually, this is really cool. But it's just like scroll too far on the right so that it's just showing this yellow and red part. The green part is gone, kind of black part is gone, and it will not change, although we're constantly scrolling. Doom scrolling. I don't know. Okay, so whatever it is. Now, what I wanted to do is, what if I could make this wordy way of making scroll in a more like a concise way, like scroll x, well, the function is not really concise, but no wrap, something like this. If we could do something like this, that can be quite nice, right? Because sometimes you want to do it and you don't want to like wrap your head around, okay, how can I do it with modulate and solid and arrow function? That's just like overwhelming. I'm used to this, but it's probably like overwhelming for a lot of people. So what if we can create scroll no wrap, so we can just like infinitely scroll noise function without seeing that edge? So in order to do this, I have to change the name to scroll x no wrap. We can find better name in the future, but let's just stick to this to be like really clear what we're doing. And I'll keep this chord, and I would rather like, yeah, keep the input values same as like what we have for scroll x. Maybe just like have a new convention that underscore scroll x underscore speed for these names. So I'm gonna just change it here. And actually this is not like a difficult assignment at all, because there's only one thing we have to change, and that is to take this fract away. This is like a GLSL territory. I'm not gonna like explain too much, but basically what scroll x does is like it's taking the fraction of st. So st is moved to the new position where it samples from the new position with the parameter scroll x, and basically essentially the speed is multiplied by time. So as time passes, it will scroll more and more. It's basic thing what's happening here, I think. But also it's taking fraction of st. So whatever it exceeds 1, it will wrap around to 0. So it's like 1.1, it becomes like 0.1, 1.2, or like 100.2 becomes 0.2. Or negative as well, if it's like minus 0.2, it becomes 0.8. Is it? I think. Yes, so anyways, So that's like wrapping around what is happening with wrapping around. Actually, now I came up with a new idea. So, okay, let's something that we can. I have an assignment that is harder to create. So for now, I'll just like do this st as no wrap scroll x, so that it's just not taking care of fract. So this is gonna like neglect all these like shape problem. It's not gonna wrap around anymore, so shape will be gone. But things like noise, Voronoi, it will just infinitely scroll, so it's kind of cool. And let's see if it works. And it doesn't do anything because I didn't assign the speed parameter here. In this case, like it's just scrolling, so the first parameter doesn't really matter. And voila. So now you don't see any seam. And it's not just like, you know, it will happen once in a while. It's never going to happen because it's just infinitely scrolling to the x direction. And probably it's easy to do something like this with y direction. Either way, like you can tweak this as y and just change all these x's to y, x's to y, y's, x's to y. Anyways, so that's one thing to do it. But also you can just like copy the scroll y function and you can do the same, that you just take this fract away. So good. And I think I will just like keep something like this, and I will take another moment, another video to talk about the next type of function, which is color. And I think color is, fortunately, like for example, Luma, yeah, the type is color. Like the name of the type is color. It's consistent. This time geometry is not geometry, but type chord. So, but before closing the video, I want to add one assignment for myself on the spot. If I can make something like wrapping, but in a mirrored way. So for example, like, let's see if I can explain it to you well. So let's just go back to the scroll X. Now I have this edge again. And for example, I have this shape that I'll make it like asymmetric, but it's symmetric in the X direction. So I'll try to make it like rotate 1.6. Okay, it's not really satisfying. So math pi divided by 2. And what if I make a scroll X that is like wrapping, but then the next wrap is like flipped? I don't know if you understand, but you see like this left arrow, let's say, and the next one I see is going to be right arrow, right arrow, like alternating. Would it be possible? I think so, but I think I have to do like some kind of math inside here, and I'm not sure if I can really do it on the spot, but let's see if I can do it. So what I really need here is the condition, and I think it's I have to work with this fract, so, and I think it actually works that now we have this, okay, so I'll do this like, again, like very wordy name, scroll X mirror wrap, and I think it's actually nice that I kind of prepare this like separate parameter for st instead of underscore st, which I can refer to underscore st later. That's something nice. Now, I need to do this here so that I haven't changed anything. I think with this fract, I think nothing has really changed, or is actually changed. Actually, this doesn't really work. So I think I have to do something like this, or no. Okay, st equals fract st. I think this is something I need to do. If I do this, it's basically the same. It's just like replacing this. What was here, fract st, is just here. It's the same thing. So it's not changing anything from the original scroll X. But what I want to do here is I need to like add some kind of condition. And I know like if else is not really cool in GLSL, do some weird tricks. but I'll just stick to like easy ones. If else, I hope that actually works. And if, so is it multiplying by 2 or dividing by 2? Let's see. st, let's say fract st dot x divided by 2 is bigger than 0.5, something like this. Then st equals fract st. No, something like this. I'm just like doing this on the spot. And okay, this doesn't work because I did 2 instead of 2.0 and wrong operand types divided. Okay, I don't know if it's something I broke it or not, but okay, I broke it. I broke it again. It says syntax error. Okay, so it seems like if else doesn't really work or what? The problem with like debugging this is really difficult because what's giving the error here with WebGL is not really about, for example, it says like error at 0, 137, but it's not really about this chunk of code, but it's like compiled with other parts of code and the whole code is evaluated. So it's giving error to this whole code that is kind of invisible. It's somewhere in the back. I think there's a way to like show it because there's also this function called GLSL instead of out that can give you some insights, but I can't really think about it right now. So I'll just try to do something here. Okay, so this here, oh, okay, so I forgot the semicolon, obviously. That was really simple, and this is not really happening. Okay, I'm making something funny now. That's kind of cool. It's not like something I imagined, but it's kind of cool, so I like it. And that's like fun part of coding. So the problem I had was that I just forgot semicolon because I'm so used to this lazy way of JavaScript coding that I don't put semicolon like here, that I don't put semicolon here. It's a style preference, but then that can backfire sometimes that you are writing like C code or I don't know, GLSL code and you forget the semicolon. So that happened to me right now. It's okay. So why doesn't it work? So if st is divided by 2 and bigger than 0.5, it's not wrapping around. Or maybe it's too big or what? Okay, this is something a little bit more interesting that I'm making like essentially like a Kaleido kind of situation here, which is quite interesting. But okay, because I'm taking fract here, so it's not gonna like go into that one. So what if I just do something like this here? Okay, yeah, because I was already taking the fract, so it will not exceed, this will not exceed 0.5 anyways. So now what it's doing is, I didn't really explain what, I told you that I'm not going to explain GLSL part. It was like more like me trying to like do the puzzle. And I can also like show it without, instead of shape, I can do like a noise. What's going to happen here is that instead of like showing these edges, it's kind of like now, you see this kind of Kaleido effect, like mirrored effect. So it's like scrolling the same pattern, but it's like flip, 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 flip. So it looks kind of continuous, but you see this mirrored effect that is like repeated, 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 like flipped, flipped, flipped. And that's possible with this addition of code. I will like share it with you. In the comment down below, you will have the link to this code that will open up in the editor, and you can try it out. And you can also make your own versions. What if you try to make scroll Y mirror wrap, or scroll Y no wrap that I just did with scroll X, and that can be a nice assignment, and I'm not going to like give you the answer because I think it's quite obvious to do, and also it may be a good exercise for you to try. So if you create something interesting out of these tutorials, please share it with us in the comment or in the online communities and so on. And also if you have questions, please comment down below, and I will see you in the next video of Hydra Book Reading Club. That is like close to the end, but now I see that actually there are more things to come, and I'm really excited about it. So stay tuned and happy coding. Bye.